Welcome to Learning with Philemon. In this video, we will be looking at what subatomic particles make up atoms. In the previous video, we discussed how different scientists contribute to our understanding of the structure of an atom. In the center of the atom, we have the nucleus that contains protons and neutrons. A proton has a positive charge of +1 and a mass of 1 atomic mass unit, or AMU. In kilograms, this is a very small number, 1.67 times 10 to the minus 27 kilograms. A neutron is neutral, has no charge, and has the same mass as the proton, 1 atomic mass unit, or 1.67 times 10 to the minus 27 kilograms. In textbooks, the mass will often be referred to as a relative mass of 1, as both the proton and the neutron have approximately the same mass. Electrons orbit the nucleus in specific energy levels. Electrons have a charge of -1 and a mass of 1 over 1,836 atomic mass units. This means that they are approximately 2,000 times lighter than a proton. When calculating the mass of an atom, the electrons are often not considered because they are so much lighter than protons and neutrons. The mass of an electron is often referred to as negligible. However, be careful not to fall into the misconception that electrons have no mass at all. Now, this model is not drawn to scale. Although the majority of the mass is in the nucleus, the size of the nucleus is tiny compared to the size of an atom. For example, the diameter of a carbon nucleus is approximately 0.000054 nanometers, whereas the diameter of a carbon atom is 0.15 nanometers. The atom is approximately 26,000 times larger than the nucleus. A common analogy used is that if the atom was a football field, the nucleus would just be a pea in the center. This is why models are not drawn to scale. If not, you would not be able to see the nucleus, or the protons, or the neutrons. The relative size of the nucleus and the atom lead us to a very interesting conclusion, that the atom is mostly made up of empty space, as there are a few light electrons orbiting around in a huge space around the nucleus. If atoms are mostly empty space, why can we not put our hand through a solid, you may ask? What prevents this is the repulsion between the electrons in your hand and the electrons in the solid atoms. To determine the number of subatomic particles present in an atom, we can simply look at the periodic table. In the periodic table, the 118 elements are represented with an element symbol, which consists always of at least one capital letter and sometimes followed by a second lowercase letter. In the case of carbon, the element symbol is simply a capital C. Above and below the symbol, you will see numbers. The larger of the two numbers is the mass number, which tells us the number of protons and neutrons present. Carbon has 12 protons and neutrons, as can be seen in the model. The smaller of the two numbers is the atomic number, which tells us the number of protons, which is equal to the number of electrons. Carbon has 6 protons and 6 electrons. As you may have noticed, there is no number that directly tells us the number of neutrons. However, if you subtract the atomic number, number of protons, from the mass number, number of protons and neutrons, you get the number of neutrons. For carbon, this is 12 minus 6, so carbon has 6 neutrons. Not all elements will have the same number of protons and neutrons. Another matter to consider is the existence of isotopes, which are atoms with the same number of protons but different number of neutrons. To learn more about isotopes, check out the next video. It also must be noted that depending on the periodic table, the mass number may not be on the top but on the bottom. If you always consider the larger number of the two as the mass number, you will not encounter any difficulties. An important concept to remember is that the number of protons defines the identity of an element. That means if an atom has 6 protons, it is carbon. In the future, you may encounter carbon isotopes with more than 6 neutrons, or carbon ions, carbon atoms that have gained or lost electrons. An excellent resource to get acquainted with atomic structure is the PhET simulation from the University of Colorado. In this simulation, you can build an atom by adding the subatomic particles, protons, neutrons, and electrons. Adding a proton to the nucleus, we get our first element, hydrogen. If you do not have an equal amount of electrons and protons, you will have a charge appear on the top right, +1 here, which indicates you have an ion. Check out my video on ionic bonding for more on ions. Adding an electron neutralizes the charge, so we have a neutral atom of hydrogen. Adding another proton immediately gets us to the next element, helium, He. Helium has a mass number of 4, so 2 protons and 2 neutrons. The atomic number is 2, so you also need 2 electrons. I will leave the rest of the elements for you to discover. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.